So when we start adding and subtracting fractions with algebraic terms, we really need to make sure that we understand the pieces that make up fractions that we can add and subtract together. And nicely about adding and subtracting fractions is we need a common denominator, and it's to do with multiples, so we can still use our multiplying factors that are involved in this. But we have to make sure we understand where the pieces are for the multiplying factors. So first of all, we need to understand factors to get lowest common multiple. So if we have 6 and 8, the lowest common multiple is going to be 24. So how do we get that? Well, we can look at it with the factors. So if I have 6 is 2 times 3 and 8 is 2 times 2 times 2, I can look at this and say, well, basically we need to share the same factors. So whatever's missing here, from here, we need to have put in. So I'm missing a 2 times 2 here. Okay, I need 3 2's in here. So I can say that's going to give me my common multiple of 24. And the same thing could be said on the bottom. I've got a 2, I share a 2. This guy's got a 3 and I'm missing a 3, so if I just include everything that I'm missing, I get my common multiple of 24. Okay, so that's one way to do it. Another way we can do it, some people like to do it this way, is they line up all the factors and say, well, I've got a 2, anything that's shared, only take one of them, and everything that's left behind, I multiply together. Okay, so that's going to give me my common factor of 24. Okay, so this one here I'll do with just the first method. So with 12, 12 is 2 times 2 times 3. With 15, I have 3 times 5. Okay, the top guy can ask himself, what am I missing? What am I missing that the other guy has? So 12 is looking over here and saying, well, I'm missing a 5. Well, 12 needs to go get itself a 5. And then that will give it the common denominator. In this case, it's going to be 60. Okay, conversely, the same thing can be done with 15. 15 is going to look up top here and say, well, I'm missing 2 2's. If I get my 2 2's, I've got my common denominator of 60. Okay, so those are kind of two strategies we can use, and it still works even though I have algebraic pieces, as long as I know what the times and divide pieces are. So if I look at this here, 12xy and 15x, okay, 12xy can be written as 2 times, we'll do prime numbers, 2 times 2 times 3 times x times y. Okay, and 15 can be written as 3 times x, and then we have times 5. I'm going to put the times 5 over here. So if 12xy looks down, okay, actually let's do it like this. I'm going to do it the same. I'm going to do the strategy up here. So I'm going to do times x times y. So here it's going to be 15 is 3 times 5 times x. So I'm just going to line everything up. And what we can then do is we can look for common factors. That 3 is common, that x is common. Okay, so we're only going to use it once, and everything else we just bring down. 1, 2, another 2, another 5, and another y. So the lowest common denominator ends up being 60 xy. Okay, so my lowest common multiple of these two numbers, even though we don't know what x and y is, we can say that we can make them up by the factors. Okay, we can generate the lowest common multiple by understanding the factor pieces. So the same thing can be done here. So I'm going to do it in this way this time, where we're going to take a look at all the factors of 3x squared. So 3 times x times x. And we can look at 6 as 2 times 3 times x. Okay, and the first guy, 3 times x squared, is looking down below him. He's saying, well, I've got the same number of x's. In fact, I've got more, so I don't need any more x's. We both have 3's, but I'm missing a times 2. So I'm going to get myself a times 2. And that's it. I've got my lowest common denominator, or sorry, lowest common multiple when I do that. The same thing can be done at the bottom here. Well, the bottom guy is looking up and saying, well, this guy's got a 3, I've got a 3. This guy's got an x, I got an x, but he's got 2 x's. I need 2 x's. And if I get myself 2 x's, I have everything that the other guy has. Okay, and we have gotten the lowest common multiple by doing this. Okay, and we do this by finding all the common factors involved. So, how does this apply? Well, we should know by this point that the lowest common denominator has to do with finding a lowest common multiple. Okay, so as fractions, we can find the lowest common denominator by the same process. Well, I know that this is 3 times 2 times 4. Oops, that's going to give me, sorry, I'm going to say that this is 2 times 4. It gives me my 8 plus 2 times 3 gives me my 6. And this guy looks over at his neighbor over here and says, well, we both have 2's, but he's got an extra 4. And I have to make sure that I have everything that he has. Okay, but the problem is if I do that, now the fraction is not the same as 1 over 6. So to keep this the same fraction or equivalent fraction, I need to make sure I do the top and the bottom of that fraction by the same amount. I need to now balance the fraction. 1/8, and notice that now if I multiply this together, 2 times 3 times 4 is my lowest common denominator of 24. But I need the same lowest common denominator here. Well, how do I find it? I'm missing a 3 that this guy has, so I've got to make sure I get a 3. But now my fraction's out of balance. I am no longer equal to 1/8. I'm now 1/24. So keep it the same, keep it an equivalent fraction. I need to do the top and the bottom by the same amount. And this is how I can show that I'm getting a common denominator. So I end up with 3 plus 4 over the common denominator of 24. So I end up with 7 over 24. Okay. Now, some of you may have a much quicker way of doing this, but it's really important to make sure you understand the pieces involved, all the factors involved. So do one more time here. So I'm going to show this as 2 times 5 plus 2 times 2. And each of these guys are saying, well, I need to get a common denominator, I need to make sure I have all the factors the other guy has. So I'm going to multiply by 5 here and make sure I balance the fraction. I need an equivalent fraction. This guy's missing a 2, so I'm going to do this, but I'm going to balance the fraction to make an equivalent fraction. So here I have 2 over 20, which is same as 1/10. Here I have 5 over 20, which is same as 1/4. Now I have a common denominator, and I can add those two fractions together. So I end up with 2 over 20 plus 5 over 20. Now I can count the numerator as the same and get the common denominator. Okay. So now we kind of already know how to do this with numbers. So how does this apply to algebraic pieces? Well, as long as I understand that these algebraic pieces are just multiplying pieces, I can do the same thing. So for this one here, we're looking at the denominator 2a and a. Well, these are times and divide factors, so I can treat them the same way as I did here. I can ask myself, what is this denominator missing that this guy has? Well, times 2. Now I have the same denominator, but I've made this fraction different. But I can make it an equivalent fraction as long as I balance the top and the bottom. So if I times 2 on the top and bottom, now I have 5 over 2a plus 2b over 2a. Now, although I don't know what a is, I know that 2a and 2a are the same denominator. If they have the same denominator, have the same size pieces, I can just add the numerator. Okay, so my denominator is 2a, but now I have to be careful because 5 1's and 2 b's can't be mixed together. I can't say they have 7. Okay, this is the same problem with common denominators. These are not common pieces. I've got 1's here, b's here. They have to be kept counted separately. We cannot put them together. Okay, these do not go together. We have to keep it as 5 plus 2b. So that's then my final answer. I've got this many pieces of this size pieces. So what about this one? Same thing. I'm missing. This guy looks over and says, well, I'm missing a times 4. So I'm going to get myself a times 4. Make sure I balance my fraction. Now I have a 12x. Okay, well, this 4 is looking over at the other side going, well, I'm missing a 3x. So he's got to make sure he's got a 3x here. But to balance a fraction, he's got to do a 3x up here. So I end up with 3x over 12x. Well, this is the same fraction. 3x over 12x is the same as 1 to 4. 8 to 12 is the same as 2 to 3. Okay, I now have a common denominator, but I'm counting 1's here, x's here. As long as I don't put them together, I keep those counting separate, I can put this all over the common denominator of 12x. Okay, so this is how we're going to deal with algebraic denominators when we're adding and subtracting.